it's not, I'm not going to label it an objective. So I asked Second Block if they wanted to, and they're like, nah. So they just put it in their binder, just so that they'd have it for a practice problem. Well, why don't you just label it whatever the other one was? Because this isn't just an extension of 19. Is that the last one we did? So just label it 19, and you can just put it, attach it to that as an extension. Okay, so here's what I'd like to do. Okay, we are still working substitution today. We are still working graphing. I'm not really going to look at elimination because elimination's not going to quite work with these. I told you that the other day. We all like elimination as far as an algebraic method to do. Most of us like elimination. This is not going to work by elimination. And so let's look at number 1. X squared plus y squared equals 25, and y equals 3/4x. All right, so we are catching in on nonlinear systems, and we're going to look at a couple of examples, and I want you to understand a couple things, okay? First of all, you need to understand what shape you're looking at, okay? If we see an x to the first power, what shape will we have? If x is to the first power, what is it? What kind of equation is it? It's linear. What shape will it be? A line. Linear is a line. So we're looking at a line. Okay, it's a Monday, right? If we have an x squared, then that is quadratic, and we are looking at a parabola. A U or an N. If you have an x squared and a y squared in your equation, this is going back to geometry. Like x squared plus y squared on the first one equals 25. Do we know what shape that will be? We learned an equation for this in geometry. What is it? A circle. Great. It's a circle. Okay? I believe you took the center point and the radius, and you had something like x minus h squared plus y minus k squared equals the radius squared, and that was your equation for your circle. Okay? So if it's got an x squared and a y squared in it, you're looking at a circle. If you have a number divided by x, like y equals something divided by x, where x is in the denominator, that is going to be a hyperbola. And it will look something like this. It's a rational equation where x is in the, where it's a fraction. Okay? It's going to be a hyperbola. So we need to understand what we're looking at. If we have a line and a parabola, so if I have a parabola and I have a line, where are all the answers for the line? On that line. Where are all the answers for the parabola? On the parabola. Where's the answer that works for the line and the parabola? Where they cross. Okay, so this one would have how many answers? 2. Is there another option there? Like not, I mean, could I draw it a different way so that it wouldn't have 2, that it might have something different? What if it looked something like this? How many answers would it have? Just 1. Okay. What if it looks like this? No answers. And I do want you to understand, we're going to look at it like algebraically. That means when you end up solving it, you're going to get an imaginary. Okay? But I don't want you to find the imaginary answers today. I want, in the real life, okay, a legit point at where they intersect. And if they don't intersect, then there is no solution. There is no answer that works for both at the same time. Does everybody understand? So I'm not going to have you find the imaginaries. But Once you realize that it's imaginary, you can say no solution. Okay, what if you have a parabola with a parabola? It could cross. How many times does that one cross? 2. It could cross once, or it could cross not at all. What if you have a parabola with a circle? How many times? That one has 2 answers. Could it have more than that? Could it have 4? 1, 2, 3, 4. And we're going to work our way up to 4 today. Could it have 3? Can someone tell me what it would look like? It can have 3. Can someone tell me what it would look like if it had 3? It's a parabola and a circle. Say it again. Put the bottom of the parabola or the top of the parabola at the point. So it would have 1, 2, 3. Very good, Julie. Okay, so it could just be 1. It could have 1, 2, 3, 4. So we're going to work all the way from no solution where they don't cross today, all the way up to where they possibly might have as many as 4 solutions. Okay? Any questions on that? All right. So let's look at the first one that we have. If we look at number 1, let's look at the equations and let's look at what we will be looking at. So x squared plus y squared equals 25 and y equals 3/4 x. What's the top equation? What shape? If it's got an x squared and a y squared, we're looking at a circle and we're looking at a line. The second one is linear, x is to the first power. You need to understand that because especially you might put it in your calculator and it may not look just so. Okay? So you need to understand that we need to see in our calculator a circle and a line. And here's what else I'm going to tell you. Remember how I told you, like Kirby asked me last week, he said, Miss Corns, give me the one way that it's going to work. And I would say, if I would put my eggs in a basket, I believe I said last week, I'd put it in substitution. Because you're going to see today, especially with circles, if it's just a line and a parabola, the calculator will probably get you your answer. Do you understand? But when you get into putting circles into your calculator and hyperbolas into your calculator, the calculator throws a fit. And it just won't go do it. And you'll see today that you're not going to be able to rely on the calculator to get all your answers. So I'm going to solve them all by substitution, and then we're going to put them in the calculator, and you'll see what I'm talking about. Okay? So let's substitute. In order to substitute, you need one equation that's either x equals or y equals. Do I have one that is either x equals or y equals? Yes. Y equals what? 3/4 x. Y equals what? What does y equal? So when I come to this second equation, the top equation, I can plug in 3/4 x. In parentheses, don't forget I still have the squared. So I took the y out and I put 3/4 x in its place. Now, the question is, can I take the 2 to everything on the inside or do I need to write it twice? Why can I take it to everything? Because it's a monomial. If you can't remember that, how many don't know when you can and when you can't? To be honest, like you can't keep straight. So what do you do if you can't remember? Write it twice always. So I will tell you, I'm going to write it twice just because for those that can't remember, because this way works all the time. But I will tell you, you can take the square to the 3. What do you get when you do 3 squared? And then you can take the square to the 4, which would be, and you can take the square to the x. So, and that's going to be the same thing that we get right here. 3 times 3 is 4 times 4 is, and x squared times x squared, when you multiply powers u, add the exponents and get x squared. All right. There are lots of ways to work this problem out. It is quadratic. Why would most of us raise our hand and go, I don't know what to do? Well, it's got exponents with it, and it's got fractions. Like, we don't know what to do with the 9 over 16. So always, what's an out to get rid of your fractions? Times everything by the denominator. So I'm going to times everything by 16. So check this out. 16x squared, what happens to the 16s here? And I get 9x squared. And then 16 times 25 is 400. Then I can combine like terms because those match. What is 16x squared and 9x squared? 25x squared. Now, what kind of equation do you have? Here's where I do not want to confuse anybody. What kind of equation do you have? So if you are one that just, how many stick with the formula no matter what? And that is perfectly fine. You can move the 400. What would be your A? 25. What would be your B? 0. What would be your C? Negative 400 once it moves over. It's got to set equal to 0. But here's what I'm going to tell you. I told some of you, I showed you a little shortcut once upon a time. And I said, if all you have is an x squared, if you don't have the b term, does that make sense? If there's no x, can I get x squared by itself? Yes. So what would I do to get x squared by itself? Divide by 25 on both sides. And so again, if this confuses you, I want to tell you to stick to what you know. Stick to your formula. Stick to your factoring. Stick to whatever you know. But this does work. How do I get rid of x squared? What's the opposite of squaring? I'm going to take the square root. And be careful. If I'm solving an equation, and I take the square root on this side, and I take the square root on this side, what's the square root of 16? Let me try it again. What's the square root of 16? What's the square root of 16? I hear one saying it. Plus or minus 4. So how many x's do I have here? 2. That means I'm going to have 2 intersections. And that should make sense because I have a circle and I have a line. So that means I've got 2 x's at this point in time. I've got a positive 4. I need to figure out the y that goes with it because I'm looking for an x comma y. And I got a negative 4. Do you understand that? So my question is, if I know my x's are 4 and negative 4, what can I do to figure out y? Plug it in, plug it in. You can go back and you can plug it into door number 1, or you can plug into door number 2 that's already solved for y and linear. This one up top's got a bunch of squares with it. It's a little more complicated. I like this bottom one right here. So I'm going to go and I'm first going to plug in 4. What happens to the 4's? So what's y equal to? 3. So down here at my point, when x is 4, what did y come out to equal? 3. So that's one intersection. Now I got to do another problem. I got to plug in negative 4 this time. So what will y equal? Negative 3. So there are your 2 points of intersection. Oops. Did I lose anybody on the fact that if you only have an x squared, you could just isolate it and take the square root on both sides? Okay. Right here. Here's your answer. There's your 2 points of intersection. Oh, what if they're just linear? What if they're not perfect squares? Is that what you're saying? We'll get to that, and you're going to see some today. If they're not perfect squares, then you're going to write them like 3 times the square root of 2. Or you're going to break them, factor tree them down, and write them like that if they're irrational. Okay? All right. So let's look at this graphically. Okay, let's look at this graphically. So, first thing, if I go back to my problem, I need to have both equations in y equals. So, my bottom one's good, but I need to rearrange this top one. X squared plus y squared equals 25. So, I need to move the x squared over. I'll have y squared equals what? Negative x squared plus 25. How do I get rid of y squared? What's opposite of squaring? I'm going to take the square root. And if I'm solving and I take the square root on both sides, what do you think? I heard it. Good. Plus or minus. Technically, you're going to have to write two equations, and I'm going to show you. Let's just put in the positive version. Let's just say we forget to take the plus or minus version. Okay? You're going to have both. So you're actually going to have to put in 3 equations. You'll have to put in the positive version of square root of negative x squared plus 25 and the negative square root of negative x squared plus 25. So you'll have to put in both of those to get the whole picture. So let me show you. Get your calculators. All right, let's look at this. Let's just put in the square root of negative x squared plus 25 and hit graph. Whoops, I need to zoom 6. What happens if I only just put in the positive square root of negative x squared plus 25? You only get half of it. Do you see why you have to have the plus or minus? So I only see half a circle. To get the whole circle, I've got to go back down and put in the negative square root of negative x squared plus 25. Does everybody understand what I did? And so now you're going to get the full circle. Did everybody get it? If you didn't get it, raise your hand. Miss Handy will come see you. Okay? Then you need to put in the next equation. You need to put in the y equals 3/4 x. So 3 divided by 4, close parentheses, x. That's going to be your line. So how many intersections does this guy have? 2. So draw that. You can sketch that on your paper. You do not have to draw it point for point, but go ahead and sketch that on your paper that I gave you today. Okay, so we know that there are 2 intersections. So here's what I'm going to tell you. I'm going to try to go get the intersection. Second calc, intersect, inner, and it's giving me 5, 0. Remember how I told you last week to be careful? Is that one of my answers? Where's 5, 0? It's an x-intercept. It's not giving me the intersection of the line and the circle. I need to get this guy up here. So what you may need to do to this is you may need to trace it you may need to trace it up to the intersection and try again. Here's what I will tell you. I tried all kinds of times in second block and I couldn't get mine. Mine kept saying error. Now I had about 5 people keep trying to trace it. Okay? Did anybody actually get theirs? Okay, so Miss Handy got hers on her calculator. Some calculators will work. Miss Handy's may work. Dylan's may work, but Lydia's may not work. Okay? Landon's may work, Brittany's may work, but Kirby's may not work. Do you understand? And Kirby's going to say, what are y'all doing that I'm doing? These machines are temperamental. You have to trace it down to the intersection. You have to play around with it. And it may or may not. I never could get mine to get my points today. Now, somebody said in second block, they said, Miss Corns, while I'm tracing, check this out. While I'm tracing, I'm over here at this point. It will estimate it for you. That says 4.04. That's pretty darn close to what? 4, and 2.9 is pretty close to 3. Isn't that one of our points, 4, 3? Does that make sense? So you can trace it over there, but to actually get you to do it, and then same thing, if I want to come get this point down here at the bottom, you have to trace all the way over to it and tell the calculator where you want it to go get. I'm going to have to use my down button. Let's go down. And let me try one more time. Calc. See if I can get it to go get it. And mine's not going. Okay, mine's not working. But she got her first one, but not her second one. So again, you can play with them. I encourage you, play with them. Trace it over there to it. Try to go get your intersection. But what did I tell you today about your calculator? It may or may not work. So do not put your eggs in the calculator basket. Okay? You will have to know substitution. Okay? And again, if you trace it over there to it, you can pretty much see our 2 points were -4, -3. And that's where the second point is, -4 down -3. And the first point was over 4 and up 3. Those were your 2 points. Any questions about that? All right, so let's go to number 2. No, that's just first lunch. 2x plus 18. Okay, let me stop. So, what are we looking at with our equations this time? What shape is the top one? It's a parabola. How about the bottom one? It's a line. Very good. Okay, so we're looking at something like this. And it may be like this. It could cross twice and have 2 answers, or it might just cross once and only have 1 answer, or it might not cross at all and have no solution. Do you understand? And these are going to be easier. If it's a parabola and a line, they're going to be, the calculator should get those. Okay, so I encourage you, let's try that way first. Let's go calculator. Everybody get their calculator out, and let's put this into our calculator and see if we can't get it. I think you can. Yep, I am. But I'm just gonna, just because I know for the most part, if this is me on the SOL, I would stick this in my calculator and I'd find the intersections. Okay? The only ones that are going to be difficult in the calculator are the circles and the hyperbolas. Those are the ones that the calculator won't always go get. Okay? Now, do we see a line and a parabola? Sort of. Will the calculator go get the intersections right now? Yes or no? Okay, let's try. Second calc, intersect, inner. Where's 426? Like, I don't see, how many intersections do I see right now? I only see 1. Yeah, over 4 and up 26 is way up there. So you know what I probably want to do? I probably want to zoom out. Okay, and I'm surprised actually that the calculator went and got him 426 because most of the time if the calculator doesn't see it, like if you don't see it on your screen, he won't go get it. Okay, I'm surprised he actually did. Okay, so second calc intersect, inner. 426. That's this guy up here. How do I go get the second point? Yeah, if I just hit second calc intersect, inner, you know what's going to go get? 426. If I do it again, you know what's going to go get? 426. You know if I do it again, you know what's going to go get? 426. How can I get this point over here? You have to trace it around. And everybody says, do you have to be exactly on the point? Just close to it. You know what I mean? Like you have to like I do with my children, how I have to say, you know, please go get this. It's right here. And I have to guide them to the answer. You have to guide your calculator. So you have to trace around to it. Then go second calc, intersect, enter. And you get negative 7, 4. So those are our two answers. 426, negative 7, 4, negative 7, 4. How many were able to get those in your calculator? Both of them. Okay. So let's solve it by substitution so I can show you what to do. Okay. So I always like to start with the smaller one. So I like to start with the linear. What does y equal? So where I see a y up here, I can plug in 2x plus 18. Let me ask you a question. Linear or quadratic? Quadratic. So let's solve it like a quadratic. Let's set it equal to 0. So let's move both of these over here. So that'll be a minus 2x and a minus 18. So 0 is equal to x squared plus 3x minus 28. Take a minute, however you want to do it. Formula, factor it, graph it, solve that quadratic. Okay? So when we solve this, I'm solving for x, and I'm going to do it by factoring just for purposes. If you are a formula person, do your formula. But I'm going to factor this into x and plus 7 and minus 4. I'm not done because I got to figure out what x is. What could I plug in for x that would make that 0? X would be negative 7. What could I plug in here that would make that 0? X would be positive 4. These are your two x's. So if it is me, I'm going to go over here and make my points. I know one of my x's is negative 7. I know one of my points is 4. Those are your x's. So when I found them, I didn't find him. I found these two. That's what I found. So to get what it is, I've got to go back up and plug into door number 1, which is quadratic and a little more complicated, or door number 2 that is linear and a little bit easier. So I'm going to go with number 2. So y equals 2 times negative 7 plus 18. So y equals negative 14 plus 18. And you can do this all on your calculator. Y equals 4. So when I plugged in negative 7, I got 4 for y. So that's 1 point. Okay, so let's look at it. Y equals 2 times 4 plus 18. 2 times 4 is 8 plus 18. And then 8 plus 18 is 26. So when I plugged in 4 for x, for that x, I got 26 for the y. Which is the exact same thing that you got when you graphed it a minute ago. But you just did it by substitution. Okay? Does that make sense? Does everybody understand when you solve this and get your x's, that means that's 2 separate points. Okay? That's 2 intersections. All right. So what I'd like for you to do, and I'm going to, we still got a couple minutes before lunch, but I want you to start on 3 and 4 and see what you can do by yourself. And then when we get back from lunch, I'll help you out. So I want you to try it both ways. I want you to try it by graphing and by substitution. All right, so let's take a look at it. This is number 3. I don't know why it says number 1, but this is number 3. Let's take a look at number 3, okay? If you put this into y equals, and I move this guy over, and you get y squared equals negative x squared plus 9, and you take the square root on either side, just know if you take the square root on one side and you take it on the other, it's got to be plus or minus. So you've got to put in plus, or just a positive negative x squared plus 9. And then you've got to put in a negative square root of negative x squared plus 9. Okay, any questions on that? And you put it into your calculator. If you put those two and this one into your calculator, I believe you end up with something that looks like this. Yay or nay? So where are all the answers for the line? On the line. Where are all the answers for the circle? On the circle. Where's the answers that are on the line and the circle at the same time? There's not. So graphically, we know that this would be no solution. Graphically, we know this would be no solution. So most of you started by substitution, and I applaud you for trying it by substitution. But let's look at it and see what happens. What does y equal? X minus 5. What does y equal? What does y equal? All right, so I'm going to go up here, x squared, and when I plug this in, guys, when I plug in a binomial, anytime I plug in with parentheses. And we talked about this, because this is a binomial, you cannot just take the 2 to the x and the 2 to the negative 5. You have got to write this twice. Don't forget to bring down your x squared and solve. You're going to have to FOIL this. And so this is going to be x squared. The outer's negative 5x. The inner's negative 5x. That's going to make negative 10x plus 25 equals 9. Here's my question. Is it quadratic? Is it linear? It's quadratic, so you got to solve it like a quadratic. 1x squared plus 1x squared is 2x squared minus 10x. And I'm going to move this 9 over and make him negative 9, so that's going to be plus 16. Now, anybody try to take this and like maybe factor out a 2 first and then try to factor it? If you did, you would realize that this is not factorable. How many did that? And you realized it's not going to work. So how else are you going to solve this one? It's not factorable. So you're probably going to have to do your formula. What's A? What's B? Negative 10. What's C? 16. So if I do my b squared minus 4ac, that's going to be negative 10 squared minus 4 times 2 times 16. And what do you get under the radical? What does that tell you if there's a negative under the radical? That there's going to be an I. There's going to be imaginary. And here's what I'm going to tell you guys today. I'm working in the real world today. I'm wanting to know for real life, right, Miss Andy? For real life. For real life, where the intersections are. I'm not working in the imaginary world. So I do not need you to actually solve it and get me an I as an answer. Does that make sense? I only want to know what my real answers are. So that the fact that this is imaginary, I can immediately just say no solution. Okay? Any questions on that? So algebraically, you end up with an I. Some people took it all the way to the final answer. What did you get with that final answer? The square root of 2i times the square root of 7 over 4. Or it depends on if you simplified it, right? Okay, and if you over 2. Yeah, if you took it all the way to that answer, you didn't need to. Okay, because again, I only want the real answers today. Okay, all right, so let's look at number 4. Y equals x squared plus 4x minus 2, and y equals 6x minus 3. This one's going to be easier to put in your calculator. Why? Because one is a parabola and one is a line, and I told you if they're parabolas and line, they're going to be easier to find. Okay, so put it in your calculator, see if you can get the intersection. I think you should come out with something that looks like this. How many intersections is it? 1. Does it go get it for you? Yes. And what is it? 1, 3 or 1, negative 3? Oh, did I not draw it right? So maybe it looks like this. So the you can trace down to it and zoom in on it. Yeah. So that's when you probably need to trust the algebraic method and know that it's just one answer. The other thing is every time I get a one answer in the calculator, I get a 0.00000 or a 0.99999. When you did it in the calculator, did you get 1.00000? Yeah, and then you got a 3.00000 or 2.9999, something like that. That tells me it's a one answer one in the calculator. Okay, and I talked to Mr. Gammons during lunch, and I said, you know, like when you put these things in the calculator, he's like, some of them work and some of them don't. I don't know why that is. And I said, okay. I was wondering if there was a specific reason why your calculator sometimes would get them and sometimes won't. Sometimes it will, sometimes it won't. So this is going to be 1, 3, something like that. Okay, if we do it algebraically, I'm going to take, and generally I start with the linear. I always take the smaller and plug into the bigger. So I can plug it in up here. Yes, sir?
So the answer you get after you solve it quadratically, that's the x.
That's your x. And then you got to find your y. Exactly. Okay, so this is quadratic. I'm going to set it equal to 0. So 0 equals x squared. This is minus 6x and plus 3. So minus 2x plus 1. I'm going to factor that into x and minus 1, minus 1. What does that tell you if they're the exact same thing? So it's just 1x. X is going to be 1. So that gives you your x value. That means, and there's only going to be one intersection right there. Okay? So you can plug it into door number 1, or you can plug it into door number 2. I like door number 2 because it's linear. It's a little bit easier. So y equals 6 times 1 minus 3. So y equals 6 minus 3. So y equals 3. So your point is 1, 3. Okay? Successfully. Yeah, awesome. Any questions? Yes. I just factored that trinomial into x minus 1 and x minus 1. X times x, and then negative 1 times negative 1 is positive 1, but when you add negative 1 and negative 1, you get negative 2 in the middle. You can totally do your formula, because I know you like the formula. And so, again, if that way works for you and it's just easier for you, do your formula. Okay? All right. So what we're going to do now is we're going to look at our quadratic sheet. All right. So if you're listening, this is number 1 on the quadratic systems practice. X squared plus y squared equals 25, and xy equals 12. All right, so I want you to find a board, and I want you to work with me. Okay, I'd love it if people were up at standing at the board. So if there's room at a board, I need you standing with me and working with me. You can, some people can have the little boards, but if there's room at a big board, I'd like you to, don't let those boards go empty. Okay? All right. So first of all, we need to understand what we are looking at here. What is my top equation? It's a circle. Very good. So my top guy is a circle. And be careful because the bottom one looks linear. But if I solve this for y, what would I do to both sides to solve for y? And I told you at the beginning of the lesson today, this is a rational equation where x is in the denominator. What shape would that be? That's a new shape. It's a hyperbola, which means it's going to look something like this and something like that. Okay, that's what it's going to look like because x is in the, it's a fraction and x is in the denominator. Okay, if x were in the numerator, then it would be linear. But because x is in the denominator, it's going to be a hyperbola. All right, in order to substitute, we got to have 1 and y equals. So I got this guy down here. What's y equal to? 12 over x. So I want you to go up top, and I want you to plug in 12 over x into the y. Okay? Is this one where I should write it twice, or can I actually square the 12 and square the x? I can square both because it's a monomial. Okay? Again, if you can't remember that, write it twice. So 12 over x times 12 over x. So 12 times 12 is 144, and x times x is x squared. All right. So I want you to study that for just a second as far as how we're going to solve. Why would we think this is confusing to us? Because x squared is in the denominator. So I want you to solve like we've always solved. Ooh, yeah, gross, disgusting, nasty. Fractions. Multiply everything by x squared. Multiply by the denominator. And let's get rid of that fraction. So what's x squared times x squared? X to the fourth. Here they cancel. They cancel. The x squareds will cancel, leaving you with 144. Because the x squareds cancel. And then over here you get equals 25x squared. All right. So this is new to us. Because why? We've never done anything to the fourth power. But I will tell you, we can solve this. So first of all, let's set it equal to 0, like we know. And I'm going to put him in the middle. Does everybody understand? So x to the fourth minus 25x squared plus 144 equals 0. Now, I would tackle this problem by factoring. Everybody says, we can't factor x to the fourth? Sure you can. Treat it like a trinomial. What times what is x to the fourth? X squared times x squared. And I need something that will multiply to be 144 that will add to be negative 25. Find me some numbers. Find me something that multiplies to be 144 that adds to be negative 25. Brianna says 16 and 9. I do agree. Negative 16 and negative 9. If you multiply a negative times a negative, you will get a positive 144. And when you add negative 16 and negative 9, you get negative 25. Okay? Now, you could factor this a little bit further into a difference of perfect squares. That would work. I did it differently from there. Here's what I did with my second block. If we don't know what x is, like sometimes it's easy, you just take the opposite. But this one's different because it's an x squared. What do we do to each piece? We could set each piece equal to 0. X squared minus 16 equals 0. And you can move this over and get x squared equals 16. And then you could do what? Take the square root on both sides. And if I'm solving and I'm taking the square root, what's the square root of 16? So how many x's is that right there? So here's what I want you to do at your boards. I want you to go ahead and make 2 points. One is positive 4 comma something and one is negative 4 comma something. But I'm not done yet. That's 2 points. I still got to set him equal to 0. X squared minus 9 equals 0. If you move him over, you get x squared equals 9. And if I take the square root on both sides, what else can x be? Plus or minus 3. How many more points is that? So how many total points is this guy intersecting? 4 different points. So one of them is 3 comma something. and one of them is -3 comma something. So what do we do? If I know x can be 4, what can I do to figure out y? Plug it in, plug it in. So I want you to do that for me right now. I want you to plug in 4, figure out what y is. I want you to plug in -4, figure out what y is. Plug in 3, figure out what y is, and plug in -3. And you know which one I would plug into? Which one? The bottom one. Y equals 12 over x, or xy equals 12. I would use the linear, or it's not really linear, but it's a rational. Not necessarily, but yeah. Probably 99% of the time, yeah. For this. When you plugged in, any questions? When you plug in 4, you come out with 3. When you plug in -4, you come out with -3. When you plug in 3, you come out with 4. And when you plug in -3, you come out with -4. My question is do you want to see it in your calculator? No? Are y'all just going to stick to substitution? Yep. I will tell you this. Let me just draw it for you. If you plugged this into your calculator, I'm thinking the first one's a circle, so it looks like this. And it looks like it only touches once if you put it in your calculator, but this, if you zoom in on it, this is what it actually does. So it looks like this, and then it looks like this. So it has 1, 2, 3, 4 points of intersection. But you have to zoom in on it because it actually looks like it does something like this, and it looks like it only touches once, but it actually, if you zoom in, it touches twice. Okay? Any questions on that in your calculator? And this would be one, I told you with the circles and the hyperbolas, this would be one that the calculator's probably not going to want to go get. Okay, so substitution's going to be your way. All right, let's go to number 2 real quick. All right, so number 2, y equals x squared minus 9, and x squared plus y squared equals 9. We're looking at a parabola. We're also looking at a circle. Okay? So, and I think it's going to look something like this and something like this. So guess what? It's going to have 4 answers. Okay? So, I'm going to take this and plug it in for the y. So I'm going to have x squared plus x squared minus 9 squared equals 9. You got to write it twice, and you got to FOIL it. Okay, so x squared minus 9 times x squared minus 9 equals 9. Okay, so no, you're only solving, that's just for one equation. I'm looking for what x's work for both of them. So when I FOIL this, this is going to make x to the 4th minus 9x squared minus 9x squared plus 81. When I combine like terms, this will be x to the 4th, x squared plus x to the 4th minus 18x squared plus 81 equals 9. 1x squared and negative 18x squared is negative 17x squared, and if I move the 9 over and set it equal to 0, I have plus 72. From here, you can factor that into x squared, good Julie, x squared minus 9 and minus 8, because negative 9 times negative 8 is positive 72, and when you add negative 9 and negative 8, you get negative 17. Again, this is going to you got to set each equal to 0. Okay, so x squared minus 9 equals 0. So x squared equals 9. So when I take the square root on both sides, it's plus or minus 3. So how many x's is that? 2. 1 plus, 1 minus. Okay, then x squared minus 8 equals 0. This one's a little tricky because you get x squared equals 8, but what's the square root of 8? Yeah, you're going to have to break it down. I can circle a group of 2's. So plus or minus. Plus or minus 2 times the square root of 2. So here's your 4 points. 1, 2, 3, 4. We got plus or minus 3, so I got a positive 3 and a negative 3 for my x's. And then I got a positive 2 times the square root of 2, and I got a negative 2 times the square root of 2. So how could I figure out my y's? Plug them in, plug them in. So how many different problems will that be? 4. You got to plug in 3 and figure out the y. You got to plug in negative 3 and figure out the y. You got to plug in 2 times the square root of 2 and figure out the y. And then you got to plug in negative 2 times the square root of 2. All right. So listen carefully, just so I can stop my recording. You are to finish. I just want you to attempt 3 and 4 for me. Okay? Attempt 3 and 4 for me.